Welcome to the lecture on theory of melting. So, in this lecture we will discuss about types of furnaces which are required for melting purposes in casting industries. So, what we need to understand that the furnaces are very important, the kind of furnaces, there are different types of furnaces, and also a furnace normally is a cell, and there you have on the inner side you have the lining, and from the outer side you will have certainly to give it a rigid shape, you will have the metallic shell, and the lining also is important because that lining depends, or it basically is dictated by what kind of metal you are melting, especially when you have slags of acidic or basic nature. In that case you have to have appropriate type of lining. So, now the furnace is the one where the molten metal is actually melted, and you will have certainly to have some heat source that is to be used for melting the metal or the charge. So, that is why now in certain cases in some foundries when you are basically melting the non-ferrous material, so you do not require that much of high temperature, whereas when you have to melt the ferrous materials like iron or steel, especially steel, in that case you need the furnace where the heat requirement is, which can give you large temperature. So, when typically you are going to make these non-ferrous materials like aluminum or magnesium or zinc or so, which has the lower melting temperatures, you can go for the furnaces which gives you lower temperature, maybe like you can go for muffle furnaces, you can go for crucibles furnaces or so. Whereas when you require to melt steel, in that case you require to have the furnace which should give you very high temperature. Also, if you are trying to melt the material in a large quantity, in that case you require the furnaces where the heating rate is quite high. So, in that case you go for the furnaces like electric arc furnace, induction furnace or so. So, basically depending upon the nature of material you choose the furnace. Another furnace which has been very popular for iron melting has been the cupola. So, cupola is used because in cupola we use the coke, and coke is a source of carbon. So, when we are basically melting iron, that normally the variety of cast iron, in that case the carbon certainly carbon content is more than 4, or carbon equivalent value is more than 4 in that case. So, carbon percentage may vary from 3 to even 4 or so. So, in those cases the coke acts as the rich source of providing the carbon. So, cupola is one of the very important furnace which is used in the casting industries, but because of the environmental concerns some furnaces are getting less or less importance with time, like cupolas are not very much favored in certain areas where the environmental concerns are there, because it emits a lot of gases, greenhouse gases, which are basically doing harm to the environment, or certainly to certain monuments like Taj Mahal or so. So, that is why in those regions these cupolas are banned. So, basically you have different kinds of furnaces, but as far as the furnaces are concerned, its primary objective is that here you are basically melting the metal, and this molten metal is used for further pouring into the cavity. Now, what we see is that you have the factors in addition to production requirement and casting specification, all the factors which are important for governing the choice of furnaces. First is metal chemistry. So, this metal chemistry means like you have what kind of composition is there for the metal, you have whether the metal has a chilling tendency. So, that way also it will be decided. Then shape and composition of the available raw materials, what kind of raw materials you have available. So, based on that also you will have to have the choice of furnace. So, if the available raw material is bulky, if the large pieces, then certainly you will have to have the furnaces which can melt them. So, you require the furnace of larger heat input rate. So, that way depending upon even the raw material also you have to decide what kind of furnace you have to select. Then comes the metal temperature, what temperature you require to achieve. So, if you require to achieve higher temperature, very high temperature, you will have to go for induction furnaces or electric arc furnaces, whereas if you go for the lower furnaces, lower temperature furnaces, and if the requirement is to achieve suppose close to 500, 600 or 700 or even 1000, in those cases you can go for other kind of furnaces which do not require very large amount of investment. So, these electric arc furnaces or induction furnaces require large amount of investment, but the other furnaces require less amount of investment. So, basically it is all because of the temperature which you can achieve in those furnaces. Now, again the next point is metal delivery rate. So, what will be the metal delivery you are going to get in certain time. So, again that depends upon what kind of furnace you are going to choose. So, if you have the small furnace, it will give you small amount of material. If you are taking large furnaces, it will give you large amount of material in one lot, but then for that you require to invest more. You require to have a large furnace with more and more power input, so that it can do the melting and it can give you the material melted. Then the last point is melting cost. So, that is also important, because it depends upon that what kind of industry you have. If it is a small foundry, it will not try to go for very costly furnaces. So, but then the melting cost, if you look at, maybe if we see the melting cost, that like we can say the induction furnaces, or you can say the electric arc furnaces. In the induction furnace, in a very quick time you are able to melt it, although its investment cost is quite high, but then if you look at the melting cost, the electricity cost which is the input cost, it is very less, not very high. But then depending on the type of fuel also, in that case you have the type of fuel which is environment friendly, whereas if you go for using the coke or other kind of fuel, sometimes that is not environment friendly. So, that also is one of the important factor. So, for that you will have to have an adjustment or a compromise between the investment cost and the cost basically which is required for operating. So, many a times you have investment cost is less and operating cost is more, whereas in some cases investment cost is more, but operating cost is less. So, you will have to have a compromise between the two, and then you can select the appropriate type of furnace. The normal furnace which are normally used are the following type. So, the different type of furnaces which are used in foundries are like crucible furnace, open hearth furnace, reverberatory furnace, rotary furnace, cupola furnace, electric arc furnace and induction furnace. So, these are the normally used furnaces which are used for melting the material, and low to medium to even large foundries go for using the different kinds of furnaces. So, we will go one by one to see that how some of the important furnaces, what are the typical characteristics of these furnaces, what is the working principle of these furnaces. So, coming to crucible furnace. So, as you see, this is a crucible furnace So, in this basically you have a crucible which is normally made of clay or graphite, and then this crucible will be kept, and there will be heating source, and through this heating source this crucible is heated, and the molten metal which is kept in the crucible normally that is melted. So, normally it is used for various a small quantity of material can be normally is held, but you can have the larger crucible. You have the crucible numbers, sometimes you have different numbers, and that is basically specified by amount of copper which can be melted into that particular number of crucible. So, kgs of copper which can be melted like that. So, if there is a large crucible, certainly you need a large casing, and in that it has to be put in. You will have the refractory which is rammed from the sides, and then you will have the heat source, and then using that heat source you can heat the liquid metal which will be melted. So, as you see, you will have a ladle, you have the fire brick lining, and then this is the chimney, this is the cover. So, you can take the cover out, and this is the air blower. So, that will be blown, and then this way the heating will be done, and due to the heat the metal is melted here. So, it is normally convenient for smaller foundries, so that for handling these smaller quantities you have to take this crucible out. So, for smaller foundries, when you have to melt in small quantities, these crucible furnace are basically important. Now, they may be basically coke fired or the oil or gas fired. So, basically when you have to use this normally for non-ferrous melting, non-ferrous metal, these coke fired furnaces are used, and because you have the low installation cost in that, low fuel cost and ease in operation. So, because of these reasons, these coke fired furnaces are used for non-ferrous metal. Now, you have also the oil and gas fired furnace. So, as the name indicates, you have oil or gas which are used as the heating source in such furnaces. So, basically they are cylindrical in shape, and then the flame is produced by heating of this atomized fuel. So, they will combine with the air, and then they will be heated, and then they will be sweeping around the crucible. So, that way it will have the enveloping the crucible, and then uniformly heat the crucible. So, this way you have the combustion products will be coming into the contact with the charge, then they will be heating it, and then that way you can melt them, and by tilting you can take the metal out and pour it into the mold. So, you have certain advantages of this oil or gas fired furnace, like you do not have any wastage of fuel. So, that is one of the. So, here this is the oil or gas fired furnace, you do not have much of the wastage of the fuel. So, you have more thermal efficiency. Okay, in the case of oil or gas fired furnace, you have better temperature control by controlling the flow of these gases. By controlling through a knob, you can have accurate control of the temperature. Contamination will be less in the case of these oil or gas fired furnaces. So, it will also save the floor space, and you have also the low labor cost, because here you need one person just simply to regulate these burners or so. So, this way you have these crucible furnaces, and they are the different types, and normally you will have these used by the smaller foundries where you have low quantity of metal is to be melted. Then comes the open hearth furnace. So, normally you use it for melting steel or producing steel from pig iron. So, directly for casting. So, that way this open hearth furnace is used. Now, this furnace is used it has certain characteristics. So, basically the regenerative principle of heating is used. So, the combustion products which are basically coming out, they are further used so for preheating the gaseous fuel and air. So, the outgoing products of combustion will be used for preheating these the fuel and the air. So, this way the energy is basically utilized. So, and since it is preheated, so the thermal efficiency becomes more, it gives quickly it gets combusted, and that basically gives quite rise to the temperature which is attained. So, this is basically you have a shallow type of furnace, so the hearth is shallow, you have large length and width, but the depth is quite small. So, as you see these combustion products will go, and from here you will have these are the metal which are to be melted. So, because of this heat being in contact, they will be melting it. So, gaseous fuel which are used normally are like producer gas, natural gas or coke oven gas. These are the gases which are used for these open hearth furnaces. Next will be the reverberatory type of furnace, where you see you have again here is this furnace, you have the fire gate is there, and then you will have charging, and this hood is there. So, refractory hood will be there, then these combustion products will go, and then from there this charge. Here you will have the metallic charge which will be heated, and you can use this heat for melting the material. So, this is kind of reverberatory furnace. Now, further you have rotary furnaces also on the similar principle, where you can have the other facilities. So, these are the furnaces not much used nowadays because of the incoming of new furnaces which are more popular and based on other principles that we will see. One of the another important furnace which is used for normally for iron melting, that is grey cast iron or white cast iron or SG iron, is basically the cupola furnace. So, as you see in this cupola furnace, here you have this is a refractory line steel cell. So, this is the steel cell, and it is refractory line from inside, and you have the charging door. And what we do here is you have the alternate layer of coke, iron and limestone. So, you have charge, coke and limestone. So, coke will be like a fuel, limestone will be like a flux, and you will have the charge, that is metal, scrap, everything is there. So, alternately that is they are kept one over other, and you have a coke bed here. Coke bed is prepared in this region, and from here you want through the tuer. Basically this tuer is the opening through which we supply basically air from here. So, you will have the tuers. So, you have a cylindrical cell, and at different locations symmetrically placed normally you will have the openings. So, that is known as tuer. So, through that the air enters, and then this air goes up, and then this combustion takes place. So, initially you have a coke bed, and this coke bed basically ignites. Initially you ignite. So, that is known as firing of the cupola. Then basically what you do, once the firing is started, then you provide this is a charging of the cupola. So, you charge this coke, iron and limestone in alternate layers, and then after some time what happens, this limestone and coke, there in between there is a charge. So, it starts melting, and it trickles through that layer, and ultimately it trickles through this coke bed. So, through this coke bed it will come and it will get deposited here. So, then you have a tap hole, and in the opposite side you have a slag hole. So, tap hole is at the lower end, and the slag hole will be at the upper end. So, that the slag which is deposited in the bottom at the top surface, they will go from another hole, and that from the tap hole you can tap the liquid metal, you can get that, and go for melting. So, basically this cupola furnace is very popular for iron melting cases, because here the coke which is used is a cheaper fuel, and coke is source of basically carbon. So, the carbon pickup is quite high in this case, and normally it is mostly used for making these iron castings and mostly used by foundries. So, as we see further, you see here in this case you will have this is again the cupola. Now, this is the refractory bed, and now this is the case of cokeless cupola. Now, what happened that due to the environmental concerns, because cupola have the use of coke and coke contains sulfur. So, many a times there are many gases which are coming out, these gases are harmful. So, what happens, there was due to the environmental regulations and also because of the environmental concerns, we try to see that the coke should not be used, especially with the higher sulfur content cokes. So, in fact, the cokeless cupola was suggested in place of the coke cupola, where the coke is used, and in that case you have these refractory particles are used, ceramic particles are used, which are used as that bed. So, the bed of which was made of coke, now in place of that there is a refractory bed, and then you have the heating from the bottom may be done by the gases. So, that burner you will have, and then you have fuel. So, this burner from here it will heat the burner, the heat will come and this heat will go up, and then above you have the charge. So, this will be basically melted. So, this after melting of this charge will trickle down slowly through this refractory bed, and then you can basically have the graphite injection to compensate the carbon pickup, because if you have coke, then you have the chance of carbon pickup, because that supplies enough amount of carbon. But then since we are not using the coke bed and we are not using the coke, so in this case you must have the alternative way to have this carbon pickup. For that you have the graphite injection is there. So, that way you get, and then again you have the tap hole and the slag hole. So, this is the modification to the existing cupola. Apart from that, you have also many means to basically increase the efficiency of cupola, that is, and the varieties of cupolas are there on that name, like hot blast cupola is there, use of CaC2 is also done. Many times you have oxygen enrichment is done in the cupola, so that its efficiency increases. So, for that these cupolas are used. So, if you look at the operations which are performed in cupola, so initially preparation of cupola means you prepare the beds, you have the tuyeres in completely ready, then you fire. So, you fire ignite something at the bottom of the bed of the cupola, and then this fire is started, and once fire started, then you start charging the cupola. Then after the melting starts, soaking means the time for which the temperature is attained and it is soaked. So, it is reaching at that temperature, remain there for some time, opening of air blast, that is carried out, and then at that time the melt starts trickling down, and then you pour the molten metal in the mold. So, from there it will come through the coke bed, it will reach to the bottom, and from there you can take the metal out. Now, there are certain conditions, or there are certain data which tells that what is the requirement of air, what is the requirement of other input materials in the cupola operation. So, for that that needs to be understood that what will be the air requirements for this cupola operation. there will also be loss and gain of the alloying elements in cupola. So, that needs to be also understood, like during the cupola many a times the alloying elements are like manganese are there, or silicon is there, or even the carbon is there, whether it is there is a pickup or there is a loss. So, this is to be important. Wherever there is a pickup, then you have to see that it should not go more if it is undesirable, and if it is loss, you will have to compensate it by again addition of these ferroalloys or so. So, that also is the concern, like silicon is there, manganese there, they are likely to be lost. Sulfur may be pick up because of the presence of coke. So, that basically is to be is one of the factors affecting efficiency of cupola. So, there are many factors which affect the efficiency, like coke rate, blast rate, temperature of the air which we use. So, there are the factors which affect the efficiency of the cupola. So, these are the points which are required to be understood when studying the cupola operation. There has been developments in cupola melting, as we discussed. You have the hot blast operation where the blast temperature is increased. You have water cooled cupola, in which in place of this refractory, to decrease the consumption of the refractory, you provide there the water jacket, so that this lining life becomes more, but that will certainly decrease the temperature. So, that aspect is to be understood. Then you have application of basic lining many a times. You will have to keep that in mind, that in many cases, because of the sulfur presence, that is not advantageous for certain kind of melting, like when you are basically melting the ductile iron castings or SG iron castings. In those cases, the presence of sulfur is very deleterious. So, you will have to adequately, you will have to properly see that what kind of lining you require. So, in case of acidic lining, that sulfur you are not benefited. So, in that there is less freedom for you to control that. So, you use the basic lining in that case. Use of oxygen. So, if you enrich the blast with oxygen, that also increases the temperature. Use of calcium carbide, basically it also affects in that way, that this presence of sulfur, it controls that way, that is controlled. Cokeless cupola, already we have seen that we have the use of ceramic beds or ceramic refractory particles instead of the coke bed, and then use of sponge iron and fluxes. These are also the ones which are used in cupola melting. Then the next type of furnace is the electric arc furnace. So, as the name indicates, these electric arc furnaces are based on the arc which are developed, and you have many times these sometimes the arc is in direct contact with the metal which is to be melted, and sometimes it is indirect electric arc furnace also, where the arc is created, and this arc is created between the electrodes, and because of the temperature and because of the radiation which is there, because of this arc which is in contact with the metal, then metal is melted. So, you will have direct or indirect electric arc furnaces. These are normally the furnaces which are used for steel melting, or where the temperature of the molten metal is quite high. So, as you see, you have the direct electric arc furnace, and in this case you have indirect electric arc furnace, where you see that these are the electrodes. These electrodes are basically here the flame is produced because of the spark which is created. You have the spark basically gives the temperature high, generates high temperature, and that is able to melt this molten metal in this zone. So, this way you have either direct arc furnace or you have indirect electric arc furnaces. Now, charging which is done normally in these arc furnaces, electric arc furnaces, they are normally the steel scrap, which is 40% of heavy scrap is there in these cases, and then you have 40% will be medium scrap, 20% is light scrap. That way, that purity should be there in these cases. And you will have basically in the melting practice, what is there, you will have either the acidic slag process or you have the basic slag processes. So, depending upon the lining, either you have acidic slag or basic slag. So, if you have the acidic slag, means you have silica, that is saturated silica saturated iron manganese silicate. So, that is basically used in case of acidic slag, and in the basic slag operation, basically the attention will be paid on sulfur and phosphorus contents. So, that basically is there in the basic slag operation. So, you have use of ore and lime in case of basic slag operations. So, in the case of basic slag, you will have slag, that is CaO, SiC2, FeO, MnO, these are the constituents in the case of that basic slag. Further, you have the more important furnace which is normally used, which has very high productivity, is the induction furnace. So, because of the induction effect of the current, these furnace work. So, they are very quiet in operation. Electric arc furnaces create a lot of noise, whereas the induction furnace basically it is very quiet in operation because of induction effect. The charge basically melts very quickly, and then here another advantage is that it has the churning effect. So, many a times the mixing type of effect is also observed in such furnaces like induction furnaces. So, this is the induction furnace. Induction furnace is of two type normally. You have core type of induction furnace and coreless type of induction furnace. As you see, you have core type and you have coreless type of induction furnace. Further, you have the high frequency and also the medium frequency kind of these furnaces. So, the medium frequency furnaces are used for melting the cast iron, whereas the high frequency type is used for other applications like this. So, in that you have a lot of advantages, like it has high flexibility, there is high rate of melting for these induction furnaces. Whenever you require very high rate of melting, you go for these induction furnaces. Certainly, you require a large investment, the cost is quite high, and though no refining is possible. So, that is also one of the disadvantages. So, we have seen that you have different kind of furnaces, and you must know these furnaces, because when you go to the shop floor, you must be conversant with these different kinds of furnaces, how they work, what are the working principles, and that basically helps in understanding the mechanism of operation, further the refining which is done in many of the furnaces of different types or so. Thank you very much.